Hey everyone, and welcome to the Retro Channel, and today we're checking out this Commodore 1551 disk drive. These are the drives that were designed to be paired with the Commodore 16, which is what I have right here, and also the Commodore Plus 4, and I guess the C116. I'm pretty sure it has an expansion port. Anyway, these drives are fairly rare, and this one in particular was sent over from Vichy from the Netherlands, who's one of my viewers, and I think it works, although I'm not quite sure. And the reason I'm looking at it now is because I just watched a video from Adrian's Digital Basement where he got one of these drives. It was very smashed up, and he wasn't sure that it was working properly because it didn't seem to be able to communicate with his Commodore 16. Basically, I was curious to know what the drive LED behavior is when you plug these in, and also when they're plugged into a computer. And I thought, well, I've got a Commodore 1551, so I can easily find out. And then I realized that I don't actually know if this drive works. I can guarantee you the fact that you're watching this video means there is a problem with this drive, because if it does turn out to work, then I won't bother releasing this video. So I'm not lying when I say this drive is broken, because if it isn't broken, you'll never see this, and therefore you wouldn't know that I was lying. Anyway, let's plug this thing in and see what it does. So yeah, this is from the Netherlands, so it is a 220 volt unit. We have 240 volts nominal in Australia, but it should be fine for this. I mean, it's got a big bulky transformer, just like the Commodore 1541, and then linear power supplies. So the only difference it's really going to make is the voltage regulators are just going to run a little bit hotter than normal, but that should be perfectly fine, and it'll also double as a nice room heater. So plug this in, see what happens. Nothing happens, because we need to turn it on. Okay, so the motor's just constantly spinning and no activity on the drive LED. We do have the power light though. Power cycling it, it just does the same thing. Constantly spinning and no activity on the drive LED. Maybe that's normal. Let's hook it up to the Commodore 16, see what it does there. So it has this big chunky thing which actually plugs into the expansion port on the Commodore 16 and the Plus 4. And once we have that plugged in, we'll power on the drive. So yeah, motor is still spinning. Power on the C16. Looks like I haven't hooked up the power LED. And what is going on with that? Is that because of the drive? Oh, no. Maybe I've got a dodgy connection in this machine somewhere. Yeah, I've been playing around in this thing because I'm working on an RF replacement, which I think I mentioned about 6 months ago. Still tweaking a couple of little things with that. So yeah, that's why the image doesn't look that great. There's a bunch of checkerboarding and some gel bars hidden in there. So yeah, the drive is still spinning. It hasn't stopped spinning. And it doesn't seem to care what the computer's doing. Let's just try and access the drive. So I think F2, sure, deload star. Device not present, okay. So it's not even seeing that the drive is there. I'm pretty sure it should be default to, these arrow keys, default to device 8, but yeah, there's nothing on 9 either. So it seems this drive is totally brain dead. We can't communicate with it, and it's not even shutting off the spindle motor, which is normally something that happens during the sort of power on process of these drives. Well, at least it does with the 1541, so I assume the 1551 works in a similar fashion. So yeah, let's open this thing up and see what's going on the inside. So our 1551, yeah, it arrived mostly intact. There is a little break here in some of the vents back here, and I think this sticky tape is there to hold on maybe another piece of plastic, but they were already there when Vichy sent this drive over from the Netherlands. So it's traveled, you know, to the other side of the world in one piece, which is pretty amazing because from what I've seen, the plastic they used on these drives is absolutely terrible and has a tendency to just shatter by looking at it. So Let's open this thing up. I guess I'll have to take that tape off, otherwise I won't be able to get the lid off. Ew. It's going to leave a bunch of sticky crap. That's all right. Worry about that later. Right, should just be the 4 screws on the bottom, and that should allow us to take the lid off. And there we go. So very similar layout to the 1541 on the inside. In fact, the drive mechanism used is the same Neutronics one that they used in the Neutronics version 1541s. These are also the ones that have the tendency for the read-write heads to go open circuit. So that could also be a problem, but we'll worry about that once we get this thing communicating with our Commodore 16. So we have a MOS 6510T, so 6510 is the same CPU that they used in the Commodore 64, and I think this T version can just go up to 2 megahertz, whereas the C64 is only clocked at 1 megahertz. There's a 6525, so very similar to the 6526, I guess, but maybe there's some extra ports available or some kind of different configuration with the pinout. I'm not entirely sure. This big chip here, I guess, is some integrated logic. It's a Hitachi HD61J215P. There is a little MOS chip here. Maybe that's some kind of logic as well. In fact, there's a couple more chips here which are both socketed, and they are regular 74 LS14 and a 74 LS06. 2K of static RAM, and I'm guessing this has got to be the ROM for the drive, which is labeled 318008-01. Everything looks to be from sort of mid to late 84. Oh yeah, and we've got this hybrid package here, which I think controls all the drive stuff. I don't think there's going to be an issue with this thing. I'm leaning more towards either a CPU fault or a ROM fault, just given the fact that this thing seems to hang on startup. We're getting nothing out of it, and it's not even shutting off the motor. So yeah, I'm thinking either CPU or ROM fault. I guess it could be RAM. Could be the 6525, which sucks because I don't think there's replacements available for that. But just looking around the board, everything seems fine. I don't see any blown or damaged components, no bad traces. Everything looks good. So let's fire up the oscilloscope, see what we can see. All right, well, I guess we can do a few voltage checks while we wait for the scope to start up. So is that in shot? Can we read that? Not really. All right, guessing that's going to be ground. Let's just look on one of these logic chips. Yeah, nice good 5 volts there. So our 5 volt rail seems to be good. The 12 volt rail, well, that's going to be controlling the motor, so it seems to be good. I'm sure we can pick it up from possibly one of these. That's 5 volts. There we go, 11.97. Dare I say that's connected to the 12 volt rail? Surely it is. So yeah, everything seems good there. Voltages are good. I guess we can check the reset signal, which I assume is pin 40 on the 6510T, although we're seeing 2.1 volts, so maybe not. So is it possible? Yeah, okay. That seems to be connected to a capacitor. It goes straight up to 2.18 volts. So is the pinout different for the 6510T variant? I guess it is. Let's see, MOS 6510T pinout. It is listed on c64wiki.com, but it doesn't give us much information. It just says an NMOS 6510 variant with no NMI or IRQ. It's interesting. I guess we'll look for Commodore 1551 schematic. Here we go. Reverse engineered schematic diagram of the 1551 mainboard drawn by Jerzy Sobola. Hope I got that right. Let's have a look. Here we go, 6510T. Reset is on pin 3. Okay. What's pin 40? Probably a data line or something. Pin 40 is a clock output, which is not connected to anything. That makes a bit more sense. So we should see on pin 3, it should stay at 0 volts after I turn it on for half a second and then jump to 5 volts. Okay, it was a bit slow getting there, but maybe that's okay. Seemed a bit better that time. Alright, I think it's scope time. Alright, scope is ready. Let's turn this thing back on. There's a nice tab there to clip to. Yeah, let's go straight for that reset. Ooh, we are very zoomed in. So I'm on pin 3. We can see, you know, it's mostly at 5 volts, but it's actually pulsing the reset, which means the CPU is just constantly resetting over and over again. That's a bit strange. Would that indicate a CPU fault? Possibly. Do we have original schematics? I just want to double check. Yes. So on the original Commodore schematics, pin 1 is reset and that's going off somewhere totally different. Ah, this looks more like it. So that looks more like a reset line. What's this thing doing then? IRQ. Ah. Well then what we were seeing on the 555 is probably normal. I'm guessing it's, yeah, set up to fire off an IRQ at certain intervals. That seems fine then. Okay, so do not trust the redrawn schematics, or maybe do not trust the Commodore schematics. Yeah, okay, so these redrawn schematics have pin 1, which is actually the reset pin labeled as non-maskable interrupt, and that connects up to pin 21, which is the same as the Commodore schematics. But yeah, that NMI should be down here and reset should be up here. That's, yeah. I don't think I'm going to trust any more of these schematics because there could be more errors and I don't want to be chasing my tail for this whole video. So, pin 1 on the CPU should be reset. Alright, let's try that again. So, pin 1, power on. Yep, it's low and then it jumps high. Bring that out to roll mode. So, power on, yeah. It takes a, you know, quarter of a second and then it jumps high. That is what we expect to see from the reset line. Good. And yeah, I guess this NMI line is supposed to do that. I'm not sure what frequency is that going at. 106 hertz. Okay. Right, well, all that just to check the reset line, and it does seem fine. Let's see if it's still the same with the CPU installed. Yeah, just a little bit more noisy, but that's fine. Right, so where does our clock input come from? Ah, there we go. Pin 39 on the gate array is labeled CK, and yeah, that says 2 megahertz. Ah, there it is there. Pin 2, unlabeled. Alright, so pin 2, we have... Yep, that's a good solid 2 megahertz. Perfect. So where is... Oh, this is our ROM right here. 23128. Okay. 22 is output enable. Let's have a look at that on the ROM. Right, pin 22 on the ROM. It's sort of working, but yeah, that's only going down to about 2 volts. That certainly wouldn't be enough to trigger a low, I don't think. Yeah, that's going to be a problem. So what's driving that? That is coming up here to, okay, the little gate array, I'm guessing this guy. So pin 14 and pin 20 are labeled ROM enable and RAM enable, and they're active low. Let's take a look at those. So yeah, there's pin 14 on this little gate array, which is ROM enable, and we're seeing the same thing that we saw on the ROM itself. Yeah. So they obviously are going to look the same. Let's have a look at RAM enable. Just out of curiosity, it's pin 20. Yeah, that also looks screwy, doesn't it? So ROM enable and RAM enable look messed up. Oh, 19 also looks messed up. Doesn't even look like 19 is listed on the schematics. That's a mystery pin. Probably not connected. 18 looks messed up. 17 looks messed up. 16. 15 is just high. Oh, okay. So 16 through 19 apparently are not connected to anything, so I guess they're just floating around, doing whatever they want to do. But yeah, 14, 13 looks really bad. 13's not connected, I guess. 12 looks messed up. That is apparently PLL. Yeah, so these look good. These are the address lines coming in from, what is it, pin 6 to pin 10. Pin 5 is ground. Pin 4, I guess, is VCC. Pin 3 has a clock. Is that a clock? Is that supposed to be a clock? Oh, pin 3 is labeled data. Data from the drive mechanism? I don't know. 2 is just stuck high. What's that supposed to be? Sync. Is that synchronization pulses from the disk? And pin 1 is 15.95, 16 megahertz. 16 megahertz. That's got to be from this crystal. So everything down here looks messed up, but these, at least these higher address lines look fine. So I'm guessing the CPU is running and it's trying to execute code. I'm guessing the data bus and the rest of the address bus is probably fine, but it's not selecting this ROM or the RAM properly. So yeah, that's going to result in a non-working system. So seeing as that ROM's in a socket, I've just popped it out. Let's see what pin 22 is like, which is the output enable. 28, 27, 26, 25, 4, 23, 22. Yeah, it's still the same. You just bring that back in. So yeah, it looks like it's trying to enable the output from the ROM, but yeah, it's just not making it all the way to ground. I thought maybe the socket or the chip might be dirty, but yeah, it seems perfectly fine. Right, well, seeing as the overhead camera is already shut down, let's just pause this for a moment. I guess that'll give me time to look over the schematics and try and, wrap my head around how this drive actually works. And yeah, we'll pick this up, well, for me, probably tomorrow, but for you, in a couple of seconds. Right, we are back, and I did have a little think about this issue, but not a very long one. I did have a look on Zimmers, which is where we found the schematics, but unfortunately there's no service manual for the 1551, at least not that I can find on the web. So the closest thing I came across was a little parts list, which does list the part number for this 20-pin gate array. I mean, I guess I could always get that off a chip, but doing a quick Google search of this, it looks like this was also used in the 1541C and the 1571, and it looks like it is available from various places. But knowing that it was used in the 1541C and the 1571, well, I'm pretty sure there's a service manual for either one or both of those. So let's have a look for 1571 service manual. What I want to know is exactly how this chip works, or how it's supposed to work, and what all those different pins actually mean. So this one should do. Oh yes, 20-pin gate array, 1541B and 1571. 20-pin gate array is used in conjunction with the 40/42-pin gate array. Yeah, that is actually 42 pins. It's slightly bigger than the 40-pin ones. I wouldn't have even picked that. We're not too worried about that. At the moment, we just want to know what controls RAM enable and ROM enable. The address selector is used to produce ROM, RAM, and I/O chip select signals by decoding addresses A10 to A15. The system clocks are not gated with the address lines in this IC. All chip select outputs are active flow. Yep, cool. Right, so that means that as long as our address lines are functioning properly, we should get proper signals from RAM enable and ROM enable. And as we saw with the scope, they're only going down to about 2 volts, but it does look like it's trying to pull it down, but for whatever reason, we're not getting, down to 0 volts, so we can properly select either the RAM or the ROM. So while this chip does perform other functions as well, and I'm pretty sure some of them also looked messed up on the scope, I really just want to see the RAM enable and ROM enable lines looking right. Obviously they're not getting pulled down to ground properly, but before I go just pulling this chip out and sticking a new one in, because I'm almost certain it's this thing that is bad, let's have a bit of fun with it first. See if we can get those lines working properly without replacing this chip. Right, let's power on this drive, and I guess we'll just see, so yeah, motor's still spinning. Let's just see if these pins are still behaving the same. So it's pin 20 and pin 14 on this guy. So yeah, pin 20, that's RAM enable, still looks messed up. Pin 14 also still looks messed up. So yeah, it looks like it's just struggling to pull this signal low properly. And that also seems to be the case on some of these other lines, which like I said, we're not too concerned about right now. Let's see if we can give this chip a helping hand. So here's what I'm thinking. We're going to try and use a resistor or two to pull this line down. Obviously not so much that it can't pull it back up to 5 volts, but enough that we should get a proper low signal. This may or may not work, and it might affect the timing too much that, things will just go awry anyway, but it might be a little fun experiment. Let's see what happens. So I'm going to use the decade box just so we can work out what the ideal resistance would be, and I guess we'll actually start with pin 20, which is the RAM enable. Let's just see if we can work out what resistance we need to pull this line down without just shorting it to ground. Alright, so we're clipped onto pin 20 on this, which is RAM enable. That's going through the decade box, and the other side is connected back to ground. And we've also got the scope monitoring this signal. I've set the decade box for 10K, and these clips aren't the best, but we'll try and make it work. Alright, it's all very janky, but let's see what this does. Alright, so it's a little bit lower, I think. Pretty much spot on 2 volts, so let's go down to 9K. We'll just keep lowering the resistance. Ooh, okay. At 1K, things just get messed up. And as we keep trying to pull it down, so now we're at 600 ohms, it's just crushing the entire signal. There we go. That's pretty TTL-like, isn't it? That's 300 ohms. Okay, well that was a pretty piss-poor experiment. Let's just get that chip out, and I'll try and find another one that we can stick in there. Alright, just quickly mark up these connectors. Oh, somebody's already done that. Well, that's convenient, because yeah, none of these are keyed, so it can go in either way. Right, the board is free. Yeah, all that's in here is a big chunky transformer. Oh, and these two tabs are bent down from the factory. I know in Adrian's video he noticed these tabs were bent down, and he speculated that must have been done at the factory. So yes, confirmed. Why is there a bloody RF shield on it? How rude. Should sort it, maybe? Yeah. Ha! Bodge wires. Bodgy Commodore. And they even cut some traces down here. Huh. Right, looks like I got all the solder, but it's not just dropping out of the board, which is rude. I think it's just really pressed in there. I don't think we're going to lift anything. Let's find out. think it just needs a little bit of encouragement. Yeah, no worries. Alright, we've got a socket in. Now we just need a chip to put in there. So, here is a bunch of 1541 drive spares. I think 251-82901. Yep, that's the one we want. I hope it still works. Alright, here it is. Hopefully it works. Let's stick this in here. Cool. And stick the board back in here. I think my microphone was off for the last 20 minutes. Sorry about that. Right, we have our donor gate array installed, so let's just plug this in. I'm not even going to bother plugging in any of the drive mechanics yet. Let's just see what's happening on those two pins. So it's completely silent, but the drive is off. Oh, of course. I haven't even plugged in the power LED, but this should be currently on. Let's see. Aha. So that pins on this thing are a little bit crusty, so we did have something there. Oh yeah, there we go. So it's still not pulling it all the way to ground, but it's definitely a lot closer. It gets down to about 1 volt. So that's pin 20. Let's have a look at 14. 11, 12, 13, 14. Yeah, the pins are really crusty on this thing, so I have to sort of try and bust through some of this corrosion. Well, that doesn't look very useful at all. So we get a tiny bit of activity there and then it just stops. Let me just clean up this chip properly. So they look okay from the side, but yeah, just on top of the pins they're really crusty. I wonder if this thing is also broken. Throw a bit of contact cleaner in the socket for good measure. It's a brand new socket, but it should at least help clean up the pins on that chip. Let's try this again. Drive is on. Scope is paused. Scope is running. We're seeing nothing. Oh, there we go. That looks a bit better. So that's RAM enable. 11, 12, 13, 14. That's ROM enable, which... ah, geez. Still up at 2 volts. And we get nothing. Nothing. Something different. Lots of activity. Yeah, but that's still bad. That's bad. Well, I was almost certain that this thing was going to be faulty, but now I'm not so sure because the replacement one that I stole from a parts board, so I'm not even 100% sure that this one works, but it seems to be having the same behavior, so... back to the drawing board, eh? Right, so after searching through my other drives for another one of these chips, at first I couldn't find them. Even in this 1571, I couldn't see anything that looked like this MOS 251929 or 829, whatever it is. It turns out they used a Mitsubishi part which is labelled MN5005XCA. So apparently these are the same IC, but I started, trying to bring logic into this, and I literally brought logic into this. So I've got a logic probe connected at the moment because I'm just not sold on the fact that both of these chips can have the exact same fault. And after hooking it up and playing around a little bit, something interesting happened. Hopefully you can see it on this camera over here, but you'll notice that the drive LED is now on and the motor's not spinning. So this appears to have stabilized. It did take a few power cycles to get it this way, and if we have a look at what I caught on the logic probe, the results are kind of interesting, and in fact I can even get a new sample and it's going to look the same. So up the top we have our reset line, which is currently high as expected, and then we've got the ROM enable line, remember that's active low, and then I've just hooked the rest up to the address lines that go to this chip, which is A10 and then 12, 13, 14, 15. So apparently if all of these address lines are high, we should get an output of low on the ROM enable line, which for the most part is happening, but every so often you'll see this kind of garbage. So when everything goes high, this goes low, but then there's this little bit of crap here, and this doesn't seem to be correct. And I'm pretty sure this is to do with our voltage levels again, and even looking on the oscilloscope, I'll just go from pin 22 of the actual ROM, we can see that it is still around 2 volts. So yeah, it's only getting down to about 2 volts, and yeah, it doesn't look very pretty on the bottom of that signal. So I think that's what the logic probe is also seeing. It goes low, but it's not a stable low, so we get all this crap in between. However, the drive seems to be, I don't know if it's working properly at the moment, but everything seems to be normal. I can take multiple samples and it'll always look the same. So I don't know if it's crashed or if it's just waiting for an input from the computer. So let's hook it up to the Commodore 16. I imagine it's going to send a reset to the drive when we turn it on, so that might throw everything out of whack, but let's see if we can communicate with the drive. Yes, I'm afraid to bump any of this because these little test clips are just crap and they'll just come flying off the moment I touch one of them. All right, let's power on the computer. And the drive is spinning. And we've lost the light. So imagine if we look on here, C16 is running, device not present. So surely it's still the output of this chip that's the problem. If the address lines are solid, the chip's reacting to that, but it's just not doing a very good job of it, it's got to be this chip, right? I mean, we even took the ROM out and still on that output enable line, it still looked the same. It was, you know, only getting down to around 2 volts. Yeah, it's got to be this chip. If all the address lines are the only thing that determines, you know, what these outputs do, then we can pretty much ignore all the other things on this chip. There's the saddle canceller signal, which corrects this kind of stuff, and what else does it do? Motor speed compensator. Oh, okay, so that's what the PLL signal does. And sync data and lock are all involved in that. And yeah, here we go. This little block diagram for it. Yeah, it's only the address lines that determine what happens on these outputs. It's got to be that both these chips are just broken in the same way. It's got to be. Well, I'll pull the one out of the 1571. I guess the good thing about that is I can also put one of these chips in the 1571 and see what it behaves like in there. So let me unhook all this stuff. I'll get the chip out of the 1571, stick it in here first, see what it does, and also stick one of these in the 1571 drive, see what they do there. Yeah, doesn't take much to disconnect them. If anyone has suggestions for better probe clips like this, they just have a little DuPont connector on the other end, just like that. Put it in the comments, please. You know what I'd really love is one of those hooks that, you know, clips onto the top of dip packages. Those would be sweet, but every time I've looked them up, they're like $100 for one, which is crazy considering you've got all different size dip ICs. Right, with our Mitsubishi chip free, let's get it in this board and hope that it does something different. Let's just do the power on test. Please. It stopped spinning. No freaking way. Pin 14, 11, 12, 13, 14. Oh, that is the kind of signal I wanted to see. Oh, I can't believe that. Let's see if it wasn't just a fluke. Oh, that looks good. And again, the motor stopped spinning. Wow. So both of these, where the hell the other one went, both of these failed in the exact same way. Typical MOS ICs. Well, for the big test. Right, Commodore 16 is hooked up. Power on the drive. So the motor spins for about 3 seconds and then stops. Power on the C16. Drive spins again and stops. And it's trying to load something. And we get the drive LED. And now it's flashing because file not found. Device is present though. Ah, I can't believe that. It had me really guessing myself. I was like, surely it can't be the same fault with the same ICs. But it was. Okay, well, we need to put a disc in there and see what that does. And I just so happen to have the perfect disc right here. So even though these use the same format as the 1541 drives, obviously the computer itself is totally different. So it'll read the discs, but obviously you won't be able to load 1541 programs on this drive. But it seems this Commodore test demo disc is designed for both the 1551 and the 1541. So I guess it contains separate programs for both. Before we put that in though, we should probably clean this drive head because I don't want that to ruin my disc. Might be easier to come in from the side. Ah, it is clean. All right. Let's give it a disc. See if we can do a directory. So, is it F3? Yes. Ah, I saw the head sort of move back and forth a bit, and then it gave up. Now it won't even. Give me a directory. Do I need to like clear the error channel? Is the drive light flashing? Yes, it is. These things have a reset button. Yes, and that did reset the drive, and no, it doesn't want to give us a directory. It doesn't even seem to be able to tell where it is on the disk, so maybe these drives don't do the head banging and just rely on, being able to tell where it is on the disk to know what track to move to. I am concerned that the read-write heads on this thing are going to be not plugged in because I'm a dickhead. I was about to say open. Oh dear. Let's give that another go, shall we? Oh, piss off. Yeah. Oh, no. I'm sure the directory is still going to be on track 18, so around there somewhere. That did not work though. Seemed like a try. Oh, there's the headbang. It's a very quiet headbang though. Pretty sure this disk is good. Let's check the heads. So the drive is powered off. We're just going to check continuity. Turn that off. 15.2K. That means at least one of the coils on the head is open. So yeah, we should see pretty much, yeah, around 14 ohms or 20 something ohms between all of these pins. And it seems on this one, which is the final pin, we see 15K between all the other pins. That is not good. So we have a working 1551 with broken drive heads. Well, I ain't giving up now. So here's the plan. I have two 1541s here, and as you can see, this bottom one is the Alps mechanism. So these are the good ones, but because I want to keep sort of the look of this drive intact, I'm not going to be using the mechanism from this one. I'm going to take it from this one, which has obviously the Neutronics drive in it. So I should be able to swap over both the faceplate and this little lever onto the new drive mech, and hopefully the heads in this haven't gone open circuit, but I guess that'll probably happen over time either way. But for now, what I really want to see is a fully working 1551, because that's more interesting, in my opinion, than a fully working 1541. So let's see here. From the red wire to yellow, we have open? No. Let's go from down here. From red to yellow, we have 27 ohms. Yep. So on this one, from red to yellow, 15K. Yeah, it's definitely a bad head. I think this one, however, is still good. 13 and 26. Yep. Everything looks normal there. Cool. So these heads, at least for now, are still working. Now I've just got to liberate it. And what's interesting is I assumed all the beige colored drives are the 1541C, but this is the older board, so I couldn't have pulled one of those chips from this board anyway, because yeah, it's got, you know, separate logic for all this stuff. What are these called then? Are they just beige 1541s? I guess they are. I guess I could just swap the actual drive heads themselves, but they're a bit tricky because you've got to unhook it from this tensioner thing here. I don't want to mess around with that because I'll probably just end up knocking it out of alignment, and then I'll have to stuff around trying to align the drive, and it's easier just to pull the whole mechanism, swap it in one piece. I wonder, can we just reuse the tray? The cutouts in the metal are the same, it's just, you know, the actual cutout in the case is different. So yeah, I think the easiest way to do this is just swap the lever and this faceplate and leave everything else intact. I was going to, you know, take out the actual drive mech from each of these, but there's not really any point. There we go. Right, so they are a little different because this one has a little board with the Write Protect sensor mounted to it, and this one just sort of loops through part of the plastic on the faceplate. It just points down. Oh, I see. So the Write Protect sensor is on the top and bottom. Yeah, okay. That makes sense, I guess. But yeah, it's also cable tied into the faceplate on the bottom side as well, which is really annoying. Yeah, and you can see on this other drive mech, there's yet again another circuit board which also has the drive LED mounted to it. So they are a little bit different despite being, you know, both D500s. All right, we have the new drive mechanism installed, so this should have a good read-write head, at least for now. And of course, I swapped over the lever and the faceplate. And all we need to do now is reinstall this board, and we should be good. Okay, I think we're good. Power on the drive. Sounds good. C16 on. That looks good. Disk in, give us a directory. Yes. Okay. Oh, +4 basic demo. That sounds pretty good. Deload +4 star. Oh, it's keyboard layout. Woo. So I think this drive should be a lot faster than the 1541. I think I loaded +4 basic demo, unless there's something else called +4 something something on the disk. Oh, there we go. Ooh, color demo. Oh, 1. There you go, all the colors of the C16 and +4. Oh, that's funky. Yeah, definitely looks like shit with the stock RF modulator, but I'll have something for that soon enough. Okay, let me out. Stop. Oh, literally stop the program. I don't have sound hooked up. I think we know that this is working, right? Ooh, maybe we should do a format and test on a blank disk. All right, here's a random disk. It should be blank. If not, it's about to be. Go. How many passes? Do we want 3 passes? What the hell? You're the boss. All right. Formatting seems pretty fast. Can't really see that in the camera. I should have zoomed out a bit more. It's looking good. It's definitely a lot quicker than the 1541. If you've ever used the Jani's 1541 diagnostic, you'll know how long this performance test takes, and I think this is doing the exact same thing. It's way faster. That's just due to the very slow routines that the 1541 uses. Is that it? No, we're going to do another right track 35. Everything is okay. So, we finally have a fully working 1541 and my overhead camera just shut off. This time it's not overheating though. It just said battery exhausted. Let's just, I'll have to fix up that cable, but let's just kind of place this on top so it almost looks the part. There we go. A fully working 1551. The overhead camera just shut off. It said battery exhausted before it was overheating, and actually did something to that in the last couple of days. Stuck a big fat ass heatsink on the back of it. I've found using the thermal cam that it heats up in this sort of area, so that's where I stuck the heatsink. And now it no longer seems to overheat. The battery just dies, even though it's always plugged in. So could be a dodgy battery as well. I'll figure that out later, but we've still got these 2 cameras, so I don't think there's anything much else to see here. So there we go, a fully working 1551. Yeah, this did have me second guessing myself for quite a while, but it now works. As always, don't trust dodgy Commodore MOS logic chips that they made in-house. Adrian, if you're wondering, this is what the power on sequence is like. So the drive power's on, motor spins for a few seconds. I can't actually see what the drive LED is doing, so you'll have to work that out for yourself. And when it's connected to a computer and the drive's still powered on, it does the same thing. Spins for a few seconds and then pauses, and of course, device is present, even though it's going to say file not found because there's no disk in there. And I think these drives can also sense when you put a disk in. Yes. So the sensor at the front, as soon as you put a disc in, the spindle motor should start spinning as well for a few seconds. Anyway, that turned out to be a lot more difficult than I thought it was going to be. I thought I'd just be powering on this drive and going, there you go, that's how it works. So, I didn't lie when I said this drive was broken at the start. Just didn't expect it to be that kind of broken. Anyway, I'm rambling. That is it from me. Thank you all for watching. A huge thanks to the people that support the channel on Patreon. If you want to do the same, links to that are down in the video description. You'll get ad-free early access to all videos, along with some other perks and discounts on the Tindy store. Thank you all for watching, liking, subscribing, and I will hopefully catch you in the next one where, I don't know, we might even do the video upgrade to this machine. I'll give this drive a little bit of a wipe down. I'll be very gentle with it though, because I don't want it to break apart any more than it already has. But yeah, pretty cool to have a working 1551, given how rare they seem to be these days. Yeah, that is it for me. Thanks for watching. Bye. I'm going to need a replacement chip for my 1571. Let's see if I can get that Mitsubishi version.